Hello, my name is Mairgiotis and I come from Greece, the University of Thessaly. And in this presentation, I'm going to present the work with my collaborators Dimitra Chambra and Lysimachos Kodi from the University of Ioannina, Greece. The title of our work is Improved Hybrid Blind Image Quality Assessment using Alternative Natural Scene Statistic Characterization in the Spatial Domain. We all know that the objective evaluation of the perceived quality of an image is a growing necessity in modern image processing systems. And in the case of this work, we deal with the category of no reference, and it's important to emphasize that there is also no knowledge available about any distortion. Natural scene statistic models are used by exploiting some perceptual specific feature, either from the spatial domain or from the transform domain. We usually have an effective feature extraction procedure followed by training a regression model using those features, as we can see in figure 1, where we have a high-level overview of the proposed methodology. We have to notice that usually parametric models of generalized Gaussian density and the asymmetric form of this distribution are used to describe natural scene statistics. Consequently, support vector machine regression can map it to more accurate image quality scores. Usually, as we can see in the spatial domain, natural scene statistic features are considered from the luminance map through mean subtracted contrast normalized coefficients. In the spatial domain, we propose a flexible enough distribution to represent the histogram of our image that is affected by various types of distortion. Thus, we propose a student's distribution and we realize that the shape of our data in the spatial field is inherent in its properties. In addition, the combination of the proposed alternative statistical description together with the fastest parameter estimation algorithm help us to maintain high levels of evaluation along with computational cost reduction. We have to notice also that while the present study is related to known methodologies in image quality assessment methodologies, it capitalizes on the spatial domain's feature space, which is the first time that it's considered. In our proposed framework, the statistical behavior of the coefficients is described through the proposed parametric distribution, and moreover, the combination between this distribution, meaning student AGGT, is also investigated. But what is the rationale behind this choice? The first one is related to the investigation of whether the use of different perceptual features through alternative statistical characterization can give us a more accurate characterization of the data. Then, in this base, we can see we can contribute to improving the predictive power of or maintain high performance levels. And finally, we can improve the consequent computational costs. For example, in order to estimate the distribution parameters, we usually resort to the known EM algorithm. But here we propose a lightweight approach, which is based on the variance and the curvature of the distribution of the histogram of the data. We also have entropy features that we can use, and additional features based on ratio of energies based on density coefficients and block-based analysis, where we make use of energy sum-out ratio of density coefficients of each block, and then the coefficients of frequency variation based on frequency bands and three irradiations that we define here, as we can see in the images below in the figure 3. The rationale behind these choices is related to the rich form that is inherent to this kind of differences. With regard to the experimental results, we use the LiveC database and we have 1,000 time repetition of the experiment and 80% of the image for training and 20% of the images for testing, where the final score is the average value for all results. As we can see, we verify the importance of using the alternative statistical characterization for the known MSEM coefficients and the adjacent and the pairwise products of neighboring MSEM coefficients. The proposed distribution allows extra flexibility in the kurtosis, and we can account also for the uncertain nature of the tail of the empirical distribution. So we observe that the modeling favors the distribution of our data with the proposed distribution provide high levels of prediction while maintaining a small number of features.